Hello, welcome. Today we're going to do solving equations by extracting the root, which does involve completing the square. So hopefully you're going to go into dentistry someday. You're going to be a good dentist and extract the root. Like pull out the tooth with the root with it, but in algebra it means something else. So get yourself something to write with. Going to be doing some thinking. Thinking should go along with writing, so we have a record of the thought. So let's start off with just some basic algebra. I'm solving this equation. It's quadratic. You remember that when we simplified things, we did parentheses first, then exponents, then multiply, then divide, then add, then subtract, right? That's if you're simplifying something. Maybe you've discovered that when you solve, you go backwards. You're going to have to undo subtraction or undo addition first. And then you're going to have to undo division or undo multiplication first. And only then can you undo an exponent. And then only after you've undid the exponent can you then take care of what's inside the parentheses. So a simple example of that would be this one here. Here's my x. Right here, I notice it's squared. I'm going to have to square root both sides of the equation at some point, but not yet. I can't get to undoing an exponent until I first take care of anything that's subtracted or added. And here I see something added to it. So that's my first step. My first step is to subtract 5 from both sides of the equation. That cancels. And I get 2x squared is equal to, what is that, 32? Okay. Now I'm done with this part. Now what's next? Well, I need to undo multiply or divide. It's being multiplied here by 2. Let me undo multiply by 2 by dividing both sides by 2. This cancels. I get x squared is equal to 16. Done with that. Now I can come in here and undo the exponent. So square root the left and square root the right. And so I get x is equal to positive and minus the square root of 16, which is 4. There we go. You got to isolate that squared thing, whatever it is, before you can square root it. And pretty soon it's not just going to be a simple x that's squared, it's going to be a package that's squared. But moving on, solve this one by using the square root property. The square root property is where you take the square root of both sides of an equation. Well, in order to solve this by the square root property, I first have to make something a squared package, a squared group. If you'll notice, the left-hand side here is a perfect square trinomial. The last thing is a perfect square. The middle thing is twice the root squared. Square root of 9 is 3. Twice 3 is 6. And then the first element has got just a 1 here. So I can rewrite this as x plus 3 quantity squared is equal to 36. Aha! So now I've got something squared on the left, it's isolated, and everything else is over on the right side. Okay, let me undo the square. I do that by square rooting the left and square rooting the right. This gives me just the base. The base is all that's left there. X plus 3 is equal to plus and minus 6. Why plus and minus? Because we're saying something squared is equal to 36, so that something must be either a positive 6 or it could be a negative 6. But that's review. I've actually got two different equations now. Maybe I should stop and go x plus 3 is equal to positive 6, and another one, x plus 3 is equal to negative 6. Because then when I subtract 3 here and subtract 3 here, I get x is equal to 3. But then when I subtract, whoops, look at me, I'm rushing. X minus 3 and minus 3, this gives me x is equal to negative 9. There's my two solutions there, right? And of course what I did was this. I'm doing my reverse order of operations, parentheses, exponents, multiply, divide, add, subtract. I didn't need to do any of this. I was already at this level here. I have to undo the exponent before I can get inside that parenthesis, right? I had to get inside this parenthesis right here by removing the exponent. Then I could take care of subtracting 3. I couldn't subtract 3 while it was in that squared package. Okay, so you're going to have to learn how to factor things to get them down to a perfect square. You want something that looks like this. You want something that looks squared is equal to then something else over there on that side. That's what you want. So now solve this one using the square root property. Okay. Well, this looks fairly promising right here. Is that a perfect square trinomial? Why, yes it is. So this now factors down to x minus 5 squared is equal to 27. Okay, just simply factor x squared minus 10x plus 25. That factors down into the quantity x minus 5 squared is equal to 27. Time to square root. So square root the left and square root the right. What happens on the left-hand side? I'm just left with the base, x minus 5. But this is a problem now. This is going to be plus and minus the square root of 27. But that can be simplified. How would we do that? Maybe I even shouldn't do it right now. Maybe I should do it at the end. No, I'll go ahead and do it right now. So x minus 5, that's equal to positive and negative. Isn't root 27 root 9 times 3? Doesn't 9 come out as a 3? So this is plus and minus 3 root 3. Okay. Now, the last step is for me to add 5 to both sides. Okay. Now, what I could get here is x is equal to 5 plus and minus 3 root 3. That's an acceptable answer. You have to realize, though, that the plus and minus goes with this group right there. It does not go with the 5. Several students have made mistakes, and they've said something like, oh, plus and minus 5, 3 root 3. They put the 5 in the wrong spot. If you want to avoid that error, here's what you could do. At this step, you could say x minus 5 is equal to positive 3 root 3. And then x minus 5 is equal to negative 3 root 3. And then when you solve each one of these things individually, add 5, you get x is equal to 5 plus 3 root 3 as one solution. And then add 5. And they're not like terms because the 5 itself doesn't have a root 3. You get x is equal to 5 minus 3 root 3. And that's a separate solution. Both of those, though, can be written like this. The savvy algebra student should be able to write them like this in the end. It's a positive 5 and then plus and minus 3 root 3. Okay, this one didn't turn out to be integers. This one had a radical that was left you with an irrational answer. Make sure that you can simplify those rightly. Ooh, look at this. What am I going to do with that? Well, I could subtract 9, but is that a perfect square? If I did x squared plus 16, plus 16x minus 9 is equal to 0. Can I factor that down into a perfect square, something equals 0? No, I can't. How could I make it a perfect square? Because I need it to be something squared. Back up a little bit. Let's get rid of this. I really don't mind that 9 over there on that right-hand side. I will leave it. Let me do this. Let me do x squared plus 16x. Leave some space. Equals 9. Now, one of the things that I can do, because it's an equation, is I can add the same thing to both sides of the equation. Or multiply or divide or subtract, right? Because whatever you do to one side of the equation, you have to do to the entire other side. I, what can I add in here in red in order to make it a perfect square trinomial? And maybe you remember this from an earlier lesson. What I can do is when my coefficient on x is 1, right here, which it is, we'll do one in a moment where it's not, I can take half of my b term. Remember the b term? Remember ax squared plus bx, right? When a is 1, I'm going to take half of the b value. The b value here is 16. I'm going to take half of 16. What's 16 divided by 2? That's 8. Okay, now take 8 and square it. 64. Let me do this. Watch, watch, watch. Let me go plus 64. But if I'm going to add 64 to the left-hand side of the equation, I have to add 64 to the right-hand side of the equation, right? But now look, all of that right there, all of this right here, this is now a perfect square trinomial. I have made it a perfect square. How does it factor? X plus 8. It's always going to be the square root of this number or half of that number, because that's how we created it over here. All right. Now simplify 9 plus 64. What is that? 73? Yeah? Yeah. Okay, now it's a perfect square. I've got a squared group on the left and everything else over there on the right. So how do I undo a square? Well, you square root it. So I'm going to square root the left and square root the right, and I get x plus 8 is equal to plus or minus square root of 73. Square root of 73? I don't think that reduces. Is that a surd? Do you know that word? Surd is a word. S-U-R-D, surd. Do you know that? A surd is a irrational number that can't be reduced, like the square root of 73. But maybe a square root of 73 could be reduced. Well, let me just start dividing 73 by perfect squares. Divided by 4. Is that a whole number? No. 73 divided by 9. Is that a whole number? No. 73 divided by 16. Is that a whole number? No. 73 divided by 25 is the next one. It doesn't work. No, that's fine. Okay, so it's plus or minus the square root of 73. And so now let me subtract 8 from the left and 8 from the right. And really what I've got here is this. I've got x is equal to negative 8 plus root 73, and I've got x is equal to negative 8 minus root 73. Now, at some point, you might even want to do a decimal approximation. So just for giggles here, let me do x as approximately. So it's going to be negative 8 plus the square root of 73. What is that as a decimal approximation? I'm getting 0.5440. I go 4 decimal places. What about this one? Negative 8 minus square root 73. I'm getting x is approximately negative 16.5440. Interesting, their decimal places are the same there. Okay, so on this one, we actually made it a perfect square trinomial by adding in half of the b term squared. But if you want to add it to the left, I have to add it to the right. Then I get it here in this nice little form where I can then take the square root of both sides. Okay, so now let's talk about how to do this just in general. Find the value that must be added to make the expression a perfect square. Then, oh my goodness. Did I do that, or was that an autocomplete thing? I'm sorry. I apologize. Then write the expression as a perfect square trinomial. What do you call words that are different words, different spellings, but have the same sound? Homonyms, is that the right thing? At least that's what comes to mind. That was not planned. That was an accident. But we have to correct them when we find them. All right, so what would make it a perfect square? What would make this something, something, something squared? Take Your coefficient here is 1, okay? So take half of 12 and square it. What's half of 12? 6. Square that, 36. So plus then 36. If I added 36 right here, that would make the entire thing a perfect square trinomial, and then it would be x minus 6 quantity squared. There we go. But how do you do it when there's a coefficient other than 1? You have to factor it out. So I'm going to take this first group and I'm going to factor out just the 3. 3 times x squared plus 8x. Leave some space. Close it. Okay. What's half of the b term? Because now my coefficient inside the parentheses is 1 on x squared. So what's half of 8? 4. Square that and add it in. So plus 16. So now the 3 carries along out front, and now this is something squared. X plus 4. There we go. Okay. Now you're going to use this skill to now solve some equations. Solve this one by completing the square, because this is not a perfect square trinomial. Here's what I need to do. I need to take the c term, the constant, the thing that doesn't have an x, and I need to move it to the other side. So I do that by addition. So plus 11 here, plus 11 here. So then I'm going to get x squared plus 10x, leave some space because you're going to add something in, is equal to 11. Okay? Now, complete the square. My coefficient on x squared is 1. What's half of 10? That would be 5. What's 5 squared? That would be 25. So plus 25 on the right and plus 25 on the left. I had those switched. Plus 25 on the left, plus 25 on the right. Whatever you do to one side of the equation, you have to do to the entire other side. But now this one is a perfect square. Something something squared is equal to, what's that, 36? Oh, that's convenient, if you think about that. This is now going to be factored as x plus 5. Here we go. We're set up now to extract the root. Use the square root principle. So the square root of the left and the square root of the right. X plus 5 is equal to plus and minus the square root of 36, which is 6. So again, it's going to be then, if I subtract 5 minus 5, it's going to be x is equal to -5 plus or minus 6. But you never leave it like that if you can simplify it, all right? So I didn't mean to do that. Come on up here. Come on, come on. Come on up here. So -5 plus 6 is going to be equal to 1. And then -5 minus 6, that's equal to 11. Okay. There we go. The 2 solutions. It's amazing to me how you would ever know that you had 2 solutions for this. How about this one? Solve it by completing the square. But let's try this. You press pause on the video and you do it before you watch me do it. You do it. You try it. Go ahead. Press pause. Okay, I'm back. Now, compare your answer to mine. Here it is, right there. I'm going to move the 22 to the right-hand side by subtraction. So I get x squared plus 8x, leave space, equals -22. My leading coefficient is 1, so I'm going to take half of 8 and square that and add that in. So plus 16 here and plus 16 here. So this now becomes x plus 4 quantity squared. And that's equal now to, I better do it on the calculator. Difference between 22 and 16. Oh, that's going to be 6. -6? -6. I bet you $1 it's -6. 22 plus 16. Yeah, -6. Pay up. Okay, now I'm going to square root the left and square root the right. Oh no, do you see what's going to happen there? We are going to have to use our imagination. X plus 4 is equal to positive and negative. Never forget that. What's the square root of a negative number? I. square root of 6. Because 6 is a surd. It does not reduce. And I'm not finished yet. So subtract 4 from this side and minus 4 from this side, and I can't combine anything. So in the end, what I get is x is equal to negative 4 plus or minus I times the square root of 6. There we go. But remember, again, you know this, but remember, this is negative 4 plus I square root of 6, and it's negative 4 minus I square root of 6. You get two answers. Don't let the plus and minus in there mess with you. You get a negative 4, and then the top path plus I root 6, and then you get a negative 4 bottom path minus I root 6. You get two different answers, even if it's written kind of in one little block like that. Okay, hope you did pretty well. If not, maybe you could try the next one. Oh snap, what do you do with that? Let's get the 2 on the front. Okay, here's what I want. I want really to group those two together. And putting parentheses around them at this point doesn't really do anything computationally. It just makes my mind focus on that thing. I don't want that C term. What I want to do is I want to take this guy and pass it over to the other side. So this is now going to be 2x squared plus 6x is equal to positive 12. Okay, but the 2 in the front is going to have to be factored out. Remember we did one of those earlier when I just asked you to complete the square? Okay, I'm going to have to factor out the 2. So the 2 comes out. And what do I have left in the middle? That's going to be an x squared plus 3x, leave some space, equals 12. Oh, this one's going to be a fraction. Oh, man. Okay, we can do it. We can do it. All right, so I need to take half of 3 and square it. What's half of 3? 3 over 2. Don't do a decimal. 3 over 2 squared. What's that? 9/4 plus 9/4. And if I add 9/4 to the left-hand side, what am I going to add to the right-hand side? No, I did not make a mistake. I'm going to add 9/2 to the right-hand side. But Mr. Marsh, whatever you do to one side of the equation, you have to do to the other side. It's your own rule. You're correct. I added 9/2 to the right because I actually added 9/2 to the left. Oh no, Mr. Marsh, you added 9/4. Not really. Here's why. Not really. This 9/4 right here, if I were to multiply everything out, doesn't it get multiplied by 2? What is 2? Come on. What is 2 times 9/4? Cancel with 2 down below. Oh, 9/2. Careful. When you add that thing there inside the parentheses and you've got a factor out in front, you have to multiply the factor by that thing that you added in there to get a total amount that you added on the left-hand side. Then whatever that is, then you add that to the right-hand side. Watch out. It's got to maintain its equality. Okay, so that was just for example. I don't need that. Now, how does it further factor down? All right, so the 2 floats along out here. This becomes something squared. It's going to be x plus 3 over 2. Remember, I told you it was always half of the b value or the square root of that. Okay, now it's going to be equal to, oh good grief, I got to get a common denominator. What is 12 with the common denominator of 2? Wasn't that going to be like, oh, let me see here. I'll even do it off to the side. It's going to be, isn't that 24/2 plus 9/2 when I do that? And then you do the operation on the numerator. That's 33/2. Yes? 33/2. Okay, now what? Well, I'm going to have to get rid of the 2 out in front before I square root. So let me divide the entire left-hand side by 2, and let me divide... Oh man, this is getting busy. How do I divide the entire right-hand side by 2 when there's already a fraction there? You could multiply it by 1/2, but if you can see it like that, you can see very clearly all you have to do is just throw the new denominator of 2 into the old denominator that's already got a 2, and so it's 33/4. So this one's now, after this cancels, x plus 3/2 squared is equal to 33/4. Oh my goodness. All of that work just to get it to this point, because now we're going to take the square root. So square root the left, square root the right. X plus 3/2 is equal to plus and minus. How do you do the square root of that? It would be root 33 over 2. Because the square root of 4 on the bottom is just going to be 2, right? I'm running out of room here. So now one more step. Minus 3 over 2 minus 3. Oh, that's not coming out very well. Minus 3 over 2. This cancels. I'm out of room, so I'm going to come over here. That's going to be negative 3 over 2 plus and minus root 33 over 2. And I suppose if you wanted to, you could say negative 3 plus and minus root 33 all over a single 2. Whew. Boy, I hope that's right. I'm worried that I made a mistake. If I made a boo-boo, would you please contact me and tell me what it was and let me go back and investigate it? Because maybe I need to reshoot this video. I don't know. I think that's right. I can go back through and check all the mathematics and so forth and see if it's right. So anyway, the truths of maths are certain. You can go through and check it out. Sometimes it's the problem thinking in our own mind. Maybe we could have somebody else look at it too. 2 or more mathematicians get together and they agree on a solution. Oh, it's so much more certain than at that point. Okay, I hope you and I agree on this. And in any case, mathematics then is a continual search for truth. And that really ought to be our attitude in all areas of life, not just mathematics. It should be that way in politics. It should be that way in ethics. It should be that way in anthropology. It should be that way in psychology. It should be that way in art. What does it mean to pursue truth in art? Or maybe we're pursuing beauty more in art. But is there a true beauty versus a fake beauty in art? Ooh, that'd be a great discussion. But in any case, I wish you well. Have a great day. Bye-bye.